Welcome to Risk Engineers Talk Governance. In this last episode of Season 3, due diligence engineers Richard Roberson and Gaye wrap up the season that's had a theme on criticality and design and discuss it in the context of climate change and sustainability due diligence. We hope you enjoy the episode. If you do, please give us a rating. Also subscribe on your favourite podcast platform. If you have any feedback or topic ideas, get in touch via admin@r2a.com.au and look out for Season 4.
Hi Richard, welcome to another podcast session, and today we're actually wrapping up Season 3.
Yeah, it's our 30th, which is a bit of a surprise to both of us.
It is. There have been some interesting topics along the way, some good sessions recorded. But we're just reflecting on what we've sort of covered in Season 3, and there's been a real commonality of thread, I guess, throughout many of the sessions this season, and that's on criticality and design. And we've sort of, as many of you who have listened to us before, Richard and I have been against risk assessment for many years, the appreciation of consequence and likelihood, and so I've always focused on that criticality. But I think bringing in the design element this season, what are the credible critical issues, and then what can you do to address these? And the way that we thought we'd sort of wrap up this season was by giving an example on, a climate change or a sustainability due diligence example that we've written up in our textbook. So we think that sort of brings all of this together quite nicely.
Yeah, we had two examples in there. The first was the Aral Sea, which in the Soviet Union days, they decided to actually take the two rivers that kept the Aral Sea full and redirect them for irrigation to grow cotton, sort of a bit like the Murray-Darling Basin and growing cotton there, because cotton's a very water-hungry crop. And the consequence of this was, it worked really well. Yes, they did grow a lot of cotton, but the consequence was the water in the rivers got used up, or one of them at any rate, and the Aral Sea basically dried out, which basically was an inland sea which affected, it was a substantial area. It protected the desert and did all sorts of good things for the local community, and there was an awful lot of fishing going on, and once obviously it dries up, no more fish. And all those consequences flowed. So that was just sort of an observation about criticality and failure to take the sort of test of foreseeability and what you might reasonably expect it to do something about it. But the one that sort of is a more larger scale one is the issue of global warming. Now, climate change is sort of one of those topics that sort of everyone can get excited about, but if you just look at the CSIRO studies of seas around Australia, in the last 100 years it's increased by about a degree. What was never clear to me, I've got to say, whether it's global, the climate changes all the time. We used to have ice ages, so I never quite understood why people sort of seem to think that climate in some way is fixed. Nobody's arguing over 10,000 years ago we had an ice age, and we're apparently in a fairly warm period, but the climate continues to change. And there are other things that affect it. For example, when Krakatoa blew up, so far as I can tell, it reduced the temperature of the planet by about 1.2 degrees for a couple of years because the increased dust in the atmosphere just reflected more sunlight back, so the place cooled down. Although relying on Krakatoa to cool the planet or another event like that's possibly not the way to manage things.
Probably not. I think there'd be some better design solutions.
And the example we give in the book, if taken from a criticality viewpoint, if it actually, if it goes up by 2 degrees, everyone sort of says, the water will rise by another half a metre or something like that, which perhaps won't be too bad. But after a couple of degree warming, nobody's really too sure what happens next, because there have been times in planetary history where that occurs, and then something like the Greenland ice sheet could melt, which would raise the water level to something like 7 metres. Now, 7 metre sea level increase in Melbourne, for example, would be serious, right? Now, this basically it's a critical issue, and it's clearly credible. Is it how likely it is? Got no idea. It's certainly possible the temperature's increasing. It's certainly possible, but other things could happen. As I said, if another Krakatoa goes off, the planet will suddenly cool. In fact, one of the arguments I remember reading in the 70s, pollution was so high, it actually was cooling the planet because the particles in the air, and part of the problem we've had is actually cleaning the environment up, which is sort of one of those sort of reverse arguments that you don't really want to hear too much about. But anyway, that actually leads on to say, okay, it's a critical issue. If it happened, it would affect Melbourne, the capital of Victoria, violently. We've witnessed the Cabinet in Victoria when we had a critical issue like the drought and the desal plant Just for record, I mean, we've got a desal plant in Victoria. It costs about $5.7 billion to build. It costs us $1.6 million a day, and by the time we've finished paying it off, and if you're paying water rates in Melbourne, you will know about this, it's going to cost us about $25 billion by the time we've finished at the end of the procurement period. And we haven't taken any water from it. And you sort of got to go, well, why do we have one of these things? And the answer is it's a criticality-driven argument. If we just had 10 years drought around Australia, particularly in Victoria, and this is around when they built the thing about 2010, if you come to a view as a cabinet that there's a credible possibility that if another 10 years, if that 10 years drought continues, the drought continues for another 10 years, that a major Australian population centre could actually run out of water, like it happened in South Africa, and you have the resources to fix it in some way, what will you do as a responsible cabinet? The answer is you will put something in place to make sure it can't happen. A risk investment argument would say, don't do it, is not commercially viable.
No, but the criticality and design
basically says you have to do it. So what happens if you apply the same argument, the cabinet, and the legislation says they're required to the possibility of Melbourne flooding due to global warming? Well, the answer is, what are the options that are available to you in a design term? The answer seems to be there are currently 3 possible options. One is to put sun shields up at the Lagrangian L1 point, that's between the Earth and the Sun, so it's a negative gravity point. NASA has costed this, it's in the trillions.
Right.
Victoria can't afford it.
No, probably
not going to happen.
Probably not reasonable.
Right. The second option is to, and Cambridge University engineers have designed this, you squirt basically pollutants into the upper atmosphere to increase the albedo effect to reflect more sunlight away from the planet and cool it down that way. And for the most part, it would just be lots more clouds, because the whiter you can make it, it's like you'd be aware with snow, that the dark spots collect the heat and therefore the dark spots grow where the sunlight gets reflected off the white snow. So if you increase the cloudiness of the planet, it will reflect more heat into space. That would require putting balloons up and high pressure pumps. It actually isn't that much water, and it is actually entirely doable, but the cost is still in the multi-billion level. And there's some trials fiddling around with people trying to see what are the best types of chemical. Water vapour seems to be a popular idea, but you might want to enhance that slightly. The third one, which is the cheapest one, which frankly some idiot American already tried, is that in the Southern Ocean, which is close to where we are, around Antarctica, every year you get this giant upwelling of, with the weather changes and currents and so forth, you get this giant upwelling of nutrients that encourages algae. The krill will turn up and consume the algae, and then the whales can turn up and consume the krill. And if you put more fertiliser into these areas, you could increase the algal bloom violently. As I said, some idiot American actually already tried this. He just picked a piece of ocean, went out there with a ship and chucked a whole load of fertiliser to see what would happen. And yes, it created an algal bloom. Wasn't a particularly scientific experiment, and all the scientists sort of actually recoiled in horror. But theoretically, this would work. Now, the consequences are, to actually put shiploads of stuff down there, in the billions of dollars, it's in the same range of cost as the desal plant. Now, when you spend $5 billion on chucking
fertiliser
into the Southern Ocean at different points to see what would happen, it will increase the algae, undoubtedly. That will increase the krill, and the further consequence, presumably, would be fat whales. But these are one of the logical consequences of the argument. But this is actually something Victoria could afford and would change the climate, because it would create a carbon sink and pull by the dead algae, because the krill wouldn't consume it all, and then imagine the whales, unless they breed their population that fast, couldn't consume all the krill. So all that would sink into the very cold ocean, and it would just become a carbon sink. Now, that would reduce the human impact of carbon. If the climate is changing naturally, which it likely is anyway, it obviously won't reduce that component. So there's some delicate balances that would have to go on here. And if you were going to do this, I'd seriously recommend some validation and verification of the entire process, because if you did happen to send the climate into a total flip it, so it went into an ice age, that would be frowned upon.
Yes, it probably wouldn't be the success that you wanted to do. So by using that example, I think Richard's shown that, you know, it really is about the criticality and the design options that you could put forward to test for reasonableness, and those design options are changing
Every day.
Every day. We're just reflecting on how quickly society is changing, but also
the costing of putting up the sunshades to cool the planet. You know, so you have these spinning discs of things. That was when Elon Musk didn't have SpaceX, and if he actually gets his big spaceship going, that cost of that activity would probably decline by an order of magnitude compared to what NASA's original estimates were. So that just gives you an idea of how fast all this is changing.
So 10 years maximum, you know, these things have changed. So the options are available going forward are changing as well, but also the cost and the reasonableness, how easy things are to do, is also changing. And I'm sure we've used this example many times about the personal pilotage units for pilots on big vessels. You know, 15 years ago they were big, heavy, almost bricks, weren't they? Big laptops
giant
and contraptions,
backpacks.
and required their own backpack. Whereas now it's sort of tablet size, iPhone size. And as Richard says, the capability of all of this technology is also increasing.
Well, particularly once you start throwing AI into the mix, the way and the monitoring capability, as I can't remember if we said in the last one, was that the medical specialist. I was just talking to my GP, and he just said the medical specialists. The AI is better at diagnosing from CAT scans now than medical specialists are. And that only happened in the last couple of years, just like that.
And I think that introduction of robotics and AI is something that we're going to have to consider as engineers going forward, and what space they can play on, what role they can play in the safety space in particular. But that might be a podcast for next season.
The dangers of AI, another podcast, and the intellectual understanding of it would actually be useful. The idea that I'm going to have the opportunity to explain to Gaye what a collapsing wave function is and what Schrodinger's cat is all about is one of the more interesting things to look forward to.
Yes, I've been working with Richard for over 20 years, and sometimes I still have to ask him to repeat himself on a number of occasions to figure out what he's talking about. But that's okay. So I think that was sort of where we wanted to leave season 3. Hopefully we've brought it all together, but the key takeouts from this is really that focus on criticality and design. Next season 4, we're looking at probably doing we'd like to do some sessions on that are industry specific. So we're thinking dams and rail, aviation, possibly electrical networks and water, dams maybe. But we'd love to hear any ideas that anyone else has got out there that they'd like to hear Richard and I have a little bit of a chat about for 10 minutes or so. So thanks for joining us for season 3. We hope you enjoyed it and hope you can join us for season 4.
Thanks, Gaye.
Thanks, Richard.